All right, well, thanks for joining me today for our discussion on today's challenges that face fleet services. My name's Eric Bjornstad, and I am the Technical Information Director here with Bell Performance. And today, we're going to aim to look at some of the issues that these fleets face with respect to keeping their vehicles, keeping their engines operating at peak performance. And inevitably, when we consider this subject, this means that we will also need to consider how today's diesel fuels interface with and contribute to causing these problems, as well as we'll need to consider some of the best practice recommendations for solving these challenges and negating their effects. So any discussion that we start with respect to operational problems with fleets, any discussion like that has to consider fuel as one of the very first things. Now, today's ultra-low sulfur diesel fuels, they are associated with some issues like subpar power, like filter plugging, and fuel economy deficit, meaning loss of fuel economy or lower fuel economy than those fleets might have had with low sulfur fuel or even regular diesel fuel in times past. Beyond these, excuse me, we also see in the field issues relating to formation in the engine, poor instability, and thermal oxidation performance, poor thermal oxidation performance by today's diesel fuels, and also decreased lubricity. Although this last one is not nearly the problem now that they first expected it to be back in 2006 when they were phasing in the ultra-low sulfur diesel fuels. And largely this is because of the widespread practice of blending these low levels of biodiesel into the diesel fuel. Biodiesel has excellent lubricity. You only need 2 or 3% blended in there in order to solve ultra-low sulfur diesel lubricity issues. But even beyond these things, we're still not finished with the fleet issues that we've seen. Today, sulfur diesel fuels, they have poor low temperature operability, much worse than in times past. In other words, they jet at higher temperatures, not respond as well to cold flow treatments as as yesterday's fuels did. We have corrosion damage to injectors has been seen with ultra low sulfur diesel. Of course, water absorption problems, especially if there's this low level biodiesel content. And then, of course, microbial problems, which are a pretty serious concern, given that ultra low sulfur diesel fleets, the fuel that those fleets use, the ULSD fuel, has virtually no inherent to microbial growth. Now, there's a lot that could be said for all of these problems we just listed on the last 3 slides, and we're not aiming to do an in-depth treatment of all of these issues because that would take more time than what we have allotted today. So what we want to do is we want to focus most of our discussion on ultra-low sulfur diesel's effects on injectors, on filters, and on fuel economy. So first, let's consider this concept of fouling in today's modern heavy-duty diesel engines. Now, the fouling, this issue of fouling has been associated with problems like shorter preventive maintenance intervals, filter blocking problems, and the drivability and the power of the diesel engines that use this fuel is not really what the operators are used to. And both of these, the fouling, the loss of, or the drop in drivability and the loss of power, these things combine to make these diesel engines more expensive to operate simply because they're not performing to the level that they were designed to perform. Now, in order to understand why these ultra-low sulfur diesel fuels have these fouling issues, we have to look at how the fuel injectors of today are not what they used to be in times past. And the big reason for this is the common rail diesel engine. The common rail diesel engine design is a significant advancement over the old school diesel engine designs. These common rail systems were really developed by the industry in response to government mandates that they really had to start making significant inroads into the problems of emissions and air quality. Common rail diesels, they have smaller orifices and smaller openings. They have a lot tighter tolerances, and they operate at significantly higher temperatures and higher pressures than the diesel injectors did of the past. Now, in a typical injector found in a common rail diesel engine, you're going to get injector deposits building up usually in this area around here, typically near where the needle is and where the pintle is. Now, what kinds of fuels are affected by this fouling phenomenon? Well, what we are seeing here is that, well, first of all ultra-low sulfur diesel fuels are affected to varying degrees. But we've also seen that as you increase the amount of biodiesel content that's added to that fuel, you get a concurrent increase in injector deposits and incidences of fouling. And this is pretty much universal across the board. There's no one particular injector or injector manufacturer or engine OEM that is more susceptible than any other kind. Now, it's also fair to ask, when we ask what fuels are affected, it's also fair to ask what specific vehicles are affected. Are Honda systems more prone to injector fouling and deposit problems than, say, Caterpillars or Detroit diesel engines? Well, the injector fouling phenomenon of today is a function of the fuel, including the biodiesel content, and combined with it being a function of injector technology. So it's not really attributable to any certain manufacturer. They all have problems pretty much equally. And all of the latest common rail diesel engines, all of the latest generation of these are experiencing these problems to some degree or another. So no specific manufacturer is more to blame about this than any other one. Now, when we consider the severity of the problem, what we can see is that how severe this problem is that a particular engine or a particular vehicle model might have can be linked to things like the fuel, which we discussed. It can be linked to the pressures within the fuel rail. It can be linked to the duty cycle of that engine, and it can even be related to the time and the temperature at which the fuel soaks after the diesel the diesel engine's duty cycle is finished. Now, one thing is for certain: if you work within a fleet, if you have a fleet of vehicles under your care, you have been seeing this problem, whether you recognize it or not. So, with respect to injector fouling, what are the base causes for these injector problems? Well, a lot of this problem has to do with how the fuel has changed. Now, the removal of the sulfur to make ultra-low sulfur diesel fuel, those processes at the refinery have made fundamental changes to both the nature and the composition of the fuel. And because the fuel is now fundamentally different from a molecular and a compositional level to fuels of the past, this means it is going to change how it performs with respect to things like fouling injectors. That the hydroprocessing to remove sulfur does is it changes the ratio of the different elements in the fuel. When you're talking about nitrogen, when you're talking about oxygen, of course sulfur, because they're taking that out. Once they're finished taking out that sulfur, they have different ratios of nitrogen and other kinds of atomic constituents in that fuel. But just as this issue is that this hydroprocessing also destroys and alters previously existing stabilizers and lubricity agents and biological growth inhibitors that normally used to be historically present in that fuel. All of those have been altered and sometimes even destroyed completely in that fuel. So that fuel is now fundamentally different in a number of ways than what it was in years past. Now, removing the sulfur, say 500 parts per million of sulfur content, which is low sulfur diesel, to today's standard 15 parts per million, removing that sulfur destroys the naturally occurring antioxidants in that fuel. So without these antioxidant compounds, you get oxidation reactions that start taking place in that fuel as it sits in storage. And those oxidation reactions will form molecules like hydroperoxides if there's not a fuel that inhibits this process. So as a result, these hydroperoxides that were formed they will decarboxylate. Now that's a chemist's term. Basically, they will react and they will form heavier and heavier carbon agglomerations, and they will form soot and they will form asphaltenes. So the ultra-low sulfur diesel fuels of today, they form solids, they form gums, residue, sludge, and peroxide deposits much, much more easily than they did in years past. And this hydroprocessing also affects the ratios of the saturates and the aromatics and the olefins. Now, a saturate and an aromatic and an olefin, what those are referring to are basically kinds of carbon. Aromatics have those benzene rings that you might. Olefins are basically carbon chains that have double bonds in them, and then saturates are carbon chains that are essentially have all of their areas filled with hydrogen. Saturates are more stable than olefins, but when you start removing sulfur, when you start reacting the fuel to get the sulfur out, what happens is that you get less of these and you get more of these. And what that results in is you get more of this. You get more soot, you get more asphaltenes, you get more oxidation reactions that basically cause today's ultra-low sulfur diesel fuels to form deposits in lots of areas of the engine a lot more readily than they did in years past. So doing this, changing the ratios of these kinds of molecules has a significant impact on the formation of deposit solids. And of course, one of those is peroxide formation. So traditionally, a sister problem of the injector fouling phenomenon is also filter plugging. Typically, they are mentioned hand in hand. Someone say we have injector deposits or injector fouling, and we have filter plugging problems. So those two kinds of problems typically go hand in hand because their causes and the mechanisms in which they happen are somewhat related and have some commonalities. So in fleets, the traditional causes for filter, what are they? Well, in the wintertime, predominantly, if you had a plugged filter, it would be because of cold weather issues. You have paraffin waxes that naturally are dissolved in the diesel fuel and are part of the fuel. Well, when the fuel gets cold, those paraffin waxes become soluble, they come out gel, and they end up plugging the fuel filter. That's a phenomenon that's pretty well recognized in diesel fleets that use diesel in colder weather. You might get ice. If you get water in the fuel, and today's ultra-low sulfur diesels are more hygroscopic than before, so they attract water, and that water in cold weather will freeze, and you might have filter plugging with ice involved. Also, biodiesel saturate. Biodiesel can have a tendency to form its own kind of deposits, and you can have saturated material coming out of that biodiesel once it's been mixed into the diesel, and it will contribute to filter plugging. And then, of course, contamination by things like, let's say, microbes, microbial contamination. Microbial contamination, considering ultra-low sulfur diesels inability to resist microbial growth, you can get plugging of the filter by things like biomass. All of these things, all of these traditional causes of filter plugging in the winter are all made worse by the properties and the characteristics of today's ultra-low sulfur diesel fuel. But in the summertime, filter plugging switches gears. When the weather warms up, the causes for filter plugging that are fuel related shift away from cold weather things like diesel fuel gelling to a lot more emphasis and a lot tighter relationship to microbial actions and instability issues. So in the summertime when it's hot, you get more water condensation in the stored fuel. You're going to get microbial growth and microbial problems in stored ultra-low sulfur diesel. So you'll get filter plugging by microbial bodies, and you'll get filter plugging through by biomass, which are the biological secretions and the matrices that are formed by these microbial colonies in storage tanks. Now, filter plugging in warm weather, microbial issues can also be related to accelerated sediment formation for fuels that are stored long term. The kinds of reactions that result in the formation of sediment and sludge that will plug filters, those happen faster when the weather is warmer because chemical reactions need some kind of energy input in order to drive them. So in the wintertime, you get fuels that are plugged by cold weather issues. In the summertime, when it's warmer, you're a lot more likely to have filter plugging caused by microbial contamination or sediment and sludge formation. And oftentimes, you will get filter plugging that looks somewhat like this. This is a fuel filter, and you can see it's plugged by this black, this black deposit matter. This is probably some combination of sludge or asphaltenes. Or sometimes it can also look, separate those folds. You can see the stuff's coming off of off onto the technician's filters. This is a classic instance of the kind of filter plugging that you have probably seen many times on the ground level wherever you are at. Now, beyond filter plugging, beyond injector deposits and injector fouling, a third phenomenon to look more closely at is the issue of fleet power loss. See, over time, vehicles, they just seem to lose power. They seem like they're not driving quite like they used to. Now, to a certain extent, there's a little bit of danger in just saying, well, it just seems like there's a problem. But if you are an experienced professional that manages fleets, you have the experience to know what you should be expecting to see with your vehicles. And so when you start noticing, when it becomes serious enough that you notice it, many times it is a good idea to trust your intuition. So this phenomenon of power loss, this has been widely reported within the diesel fleet industry. And it has been reported within significant injector OEMs like Bosch, such that those companies are looking more closely at this problem. So it's not something that fuel additive manufacturers or even fleets are just inventing because they need to explain something that they're seeing. This is a real problem that is spurring action within the industry. Now, power loss by fleet diesels is linked to the injector fouling trend we were talking about before. And this makes sense because the fuel injectors are the component that's most closely associated with a vehicle's power and a vehicle's performance. See, those common rail diesel injectors that we referenced before, again, they operate at such high pressures and they have such high tolerances of 1 to 3 microns. They're operating at such high levels of performance that even the most minor, seemingly insignificant deposit buildup and tarnishing, even the most minor instances of this are noticeable, turn up to be noticeable in the drivability of the engine. So Bosch, Delphi, Siemens, they were getting reports of all this. They figured that they probably needed to do something about it. Excuse me. Fourth thing, fuel economy deficits. You can't really talk about injector deposits. You can't really talk about power loss without also talking about this term fuel economy deficits. For the layperson, we're just talking about getting lower fuel mileage than you were before. This is really closely tied to the injector issue, and because we know this, then if we're going to try and figure out why these diesel fleet vehicles are in the fuel economy that they were before, we need to start looking at injectors and injector deposits as a primary cause for this problem. Now, some fuel suppliers will say, well, no, you don't need to look at the fuel for this because they say that the ultra-low sulfur diesels fuels of today are 99.7% cleaner than they were 20 years ago, and that's true. That is absolutely true. That when you combine advances in diesel engines, especially with the common rail, and you combine with today's ultra-low sulfur diesel fuels that have been a lot more highly refined and highly processed, they are cleaner than they were before. And so these people say, well, sure, that, and if you already said we're blending biodiesel into it, 2 to 5% bio, and biodiesel is an excellent solvent. So they're saying those are not contributing to these injector problems because they're cleaner and they're better solvents than the old school diesels used to be. But that being said, the experience, what people like you who are on the ground level, you're in the trenches, you're managing the fleets, you're having to bust your butts to get the most out of what you're responsible for. The people on the ground level where you're at are seeing clearly that there are issues that have to be tied to the fuel. So these experiences in the fuel are indicating to us that if you want to keep these ever smaller, ever more powerful, more injector ports from being fouled by deposits, you need to do more than just throw your hands up and say, today's clean diesel fuel is going to keep them clean. You need to do more than that. You need to add a good fuel injector detergent. So this idea of clean diesel, this does not necessarily meaningfully reduce injector deposit formation. As we said, these injector ports are getting so much smaller and more powerful that they are increasingly affected by injector deposits. So if you add a diesel injector detergent to your fuel, what they would call in the industry a high pressure fuel injector anti-foulant, that's what the technical name that they would give it. Those have been proven to improve all of the areas where the effects of subpar fuel combustion would normally be seen. Engine efficiency, raised emissions, they will reduce those. They will restore this lost power that we were referencing, and they can maintain or even pull back some of the lost fuel economy that the fleet operators are noticing. And studies by reputable groups like the EMA, the Engine Manufacturers Association, and the JEMA, which is the Japanese Engine Manufacturers Association, credible studies by these industry groups, they're pretty conclusive that you can recover or improve fuel economy by up to 5% by keeping your injectors clean. Now, we've referenced several times that common rail diesel injectors, they operate at really, really high pressures and very, very high temperatures. And because the temperatures with these injectors are so high, the best kind of antifoulants, the best kind of injector detergents are going to be high temperature injector antifoulants. These were originally developed, as you can see, for the detergency and the stabilization of jet fuel. And typically they will be a package. They won't be just one thing. It will be a high temperature injector antifoulant package containing multiple kinds of components, stabilizers and detergents, multiple things that when you put them together, they do a really good job of remediating these problems. So they have stabilizers that prevent the formation of peroxides and deposits in the fuel and in the injectors. They have detergents to clean up existing deposits from the fuel injectors. And they also typically will have some kind of stabilization or some kind of dispersant to help with the stabilization of the fuel, in addition to the providing the detergency and the cleaning. So it's pretty clear that today's common rail diesel engines, that technology combined with the fundamental changes in the nature of ultra low sulfur diesel fuels today, when you take both of those together, there are pretty serious issues for diesel fleets with respect to injector fouling, with respect to loss of power, with respect to mileage loss compared to years past, and with respect to filter plugging. And all of these issues taken together, or even individually, are serious enough that cost really found in their best interest to take solutions for these things. And these problems are not just figments of our imagination. Today's fleets, they recognize this problem, and just as importantly, the OEMs, the engine manufacturers and the injector manufacturers, they recognize these problems too. And Bell Performance, luckily, has a solution for this with its multifunction diesel fuel treatment called Dee-Zol. Now, Dee-Zol attacks all of these problems. It attacks the black filter field problem that is seen, you've probably seen that many times where you're at. It helps restore this power loss issue. It helps address this fuel economy loss issue. Because it's a multifunction fuel treatment, it contains a package of ingredients, of active ingredients, that will address all of these issues. Now, for the issue of injector fouling, Dee-Zol contains a detergent and antifoulant package that cleans dirty common rail diesel injectors and conventional diesel fuel injectors as well, and then keeps them clean with ongoing use. See here, you have injectors that were pulled, they'd been run for 166 hours in unadditized fuel. They were dirty injectors, basically. When they ran it 48 consecutive hours with Dee-Zol, this was an accelerated test to simulate a compressed time period. And what they found is after 48 hours of running with the detergent package in Dee-Zol, cylinder number 1, you have a clean injector. 48 additional hours, see the dirty injector here, which was in cylinder number 1, is now no longer a dirty injector. So the single best thing that diesel fleets can do is use a high-quality detergent package in their diesel fuel. And that is exactly what Dee-Zol multifunction fuel treatment provides for fleets. Now, indeed, when the detergent package in Dee-Zol was tested more extensively, what they found, or what was found, is that use of the Dee-Zol detergent package showed a marked improvement in power for those engines. Here we can see a bunch of different tests, probably over 100 different tests and test readings. And these were plotting power in kilowatts measured against the diesel vehicle's runtime, number of test hours. And what you can see is that at this point here, after 979 hours of running, the power in that diesel engine had essentially degraded down to about 290 kilowatts. When they added Dee-Zol at a 1 to 1280, which is treat rate, which is 1 ounce to 10 gallons, the standard treat rate for it, what they found is that this power, as you can clearly see, began to be recovered, and only within about 150 hours of use, the power readings improved up to about 310 kilowatts. So you got a 20 kilowatt improvement, which is fairly substantial improvement for this kind of system. And Dee-Zol detergent package also not only is great for injectors, it also helps keep fuel filters clean and deposit free. These filters that you can see, they were pulled after about 12,000 miles of use. And as you can see, those filters had significant deposit, let's say deposit formation, but significant deposit accumulation within it. They are well on their way to being plugged filters. But this group added Dee-Zol, added the detergent package to their diesel fuel, and began running it. And 4 weeks later, pulled the same detergents, the same fuel filters. And as you can see, there's a huge difference between week 5 here, which was about 18,000 miles later, and week 1 here. So this is a fairly conclusive evidence that the detergent package in Dee-Zol does an excellent job of cleaning and keeping clean diesel fuel filters. So this is formulated to pretty much solve all the major problems that ultra-low sulfur diesel fuel causes for fleets. These fleets, they have certain goals in mind. They want, with respect to adding anything to their fuel. Typically, what we found is that they want to reduce their operational costs, and they want to extend their equipment life. Many times, the mileage will be a secondary option, or a secondary consideration, rather. They want to extend their equipment's life, make it last longer, and they want to reduce the operational costs, cut down on the amount, the cost of having to operate that equipment. And Dee-Zol was formulated pretty much to help those fleets meet those goals. So Bell Performance itself. Bell Performance, our claim to fame is that we invented the world's first fuel additive. We've been in business since 1909 when our company namesake Robert Bell founded the company. We started treating diesel fuel in 1954. So the world's first fuel additive was for gasoline. Bell's first fuel additive was still 1954. We're talking about 60 plus years of experience in treating diesel fuel for customers. And our mission statement, the reason why we're in business has always been about providing answers, providing products, providing services that benefit our customers. And so in this case, we believe that we bring to the table some substantial value points for diesel fleets that would definitely be worth discussing if you recognize any of these as being indicative in your situation. So in conclusion, the diesel fuels of today, when you take how they have changed and you combine them with the significant advancements in engine technologies, those two factors merging together have really changed the game for diesel fleets. And diesel fleets can no longer afford to ignore the problems that have developed as a result. But there are solutions, there are answers out there, like Dee-Zol from Bell Performance, that are both cost-effective and that will return, pretty substantial ROI back to the fleet's budget when you really start breaking down the numbers. So this brings us to the end of our discussion today. Now, if you have any questions, if you have any comments, my email is listed here, ebjornstad@bellperformance.net. Feel free to send me an email. Just reference that you were listening to the Fleet Services presentation. You have a question, you have a comment, those are always welcome. So if you have any questions or comments, or if you have some issues that you think we may be able to help with, we very much would welcome the opportunity to show you how we can help you. So thanks very much for joining me. Again, I am Eric Bjornstad with Bell Performance, and I'll see you next time. Bye.